Good day, guys. Welcome to Calcumind, and today we'll be looking at the question 2 on separation variable technique. So we get the idea earlier from our video whereby we used y equals to vx and substituted it into the equation, and also for dy over dx we use v plus x dv over dx and substituted it in place of this dy over dx, and using the separation variable technique and the direct integration technique to further break it down and later resubstituting y equals to vx into the equation. So we are going to be reapplying the whole process and working this out. So firstly, let's substitute, say let y equal to vx. So anywhere we see y, we are going to be putting in vx. Let's do that. So this dy over dx is equal to minus vx square. You can see that it has square, so it's going to be applying to both parameters. So this is going to be plus 2x vx 2x square plus 3x vx. So now we are going to be further simplifying the whole equation. So it's going to be minus v square x square plus 2vx square. That's correct. So this is going to be 2x square plus 3vx square, which is equal to dy over dx. So if you use a product rule to work on this dy over dx, whereby y is equal to vx, you're going to be getting dy over dx is equal to v plus x dv over dx. So now we are going to be substituting these all parameters into this point and working out the equation. So it's going to be v plus x dv over dx is equal to this, which is equal to minus v square x square plus 2vx square all divided by 2x square we can see now we want dv over dx, which is the same method we walked through with our previous video. If you haven't watched that, you can also check it. It's tagged in the description. So this is going to be x dv over dx minus, going to be rewriting our equation, so now this, we are going to be moving it over to this point and it's going to have a minus sign. So now we can also notice from this equation that it has x square on this side, x square on this side. So now if we take it out, they are both going to cancel. Let me show you how that works. So this is going to be minus x square is going to come out, x square v square plus 2v x square 2 plus 3v minus v, which is equal to x dv over dx. Noting that this x square also cancels this out, so this cancels out. We'll be left with this whole equation. So now we'll have v square plus 3v plus 2v rather divided by 2 plus 3v minus v is equal to x dv over dx. So now we are going to be taking LCM of both sides in order to simplify this v and make it part of the numerator for this equation. So let's take the LCM. So this is going to be all divided by 2 plus 3v. So this divided by this is 1, multiplied by this is going to be v square plus 3v minus, so this divided by this is 1 multiplied by the v. So we'll be left with v plus 3v is equal to x dv over dx. So now we are going to be working out this equation. V squared plus 3v minus 2v plus 3v squared. 2 plus 3v is equal to x dv over dx. So now we are going to be summing up the equation. So now we are going to be working out this equation. So we can notice that x squared is common here. So we'll take it out. So this is going to be minus x squared v squared plus 2v all divided by x squared 2 plus 3v, which is going to be equal to x dv over dx. So now these two parameters cancels out. Okay, we omitted our minus v. These two parameters cancels out. We'll be left with minus v squared, whereby this minus multiplies this, minus 2v all divided by 2 plus 3v, which is equal to x dv over dx. So now, okay, let's add our minus v. So now, if we take the LCM in order to eliminate this v and make it part of the top equation, we'll be taking the LCM, which is 2 plus 3v. Let's write this out properly. Minus v is equal to x dv over dx. So now, if we take the LCM, it's going to be this divided by this is 1 multiplied by the whole equation is still the same, minus v squared minus 2v. So this divided by this is 1 multiplied by minus v. So it will be minus v 2 plus 3v is equal to x dv over dx. So now if we multiply through, we'll be having minus v squared minus 2v minus 2v. This multiplied by this is minus 2v minus 3v is equal to x dv over dx. So now we'll be working through with the other equations. So now we are going to be cross multiplying. So this minus 4v squared minus 4v dx is equal to 2 plus 3v x dv. So now we are going to be dividing all through. We want the v's to be on one side and we want the x to be on one side. So this, we have the v's on one side. We are going to be dividing through by the x. So what we are going to be doing is multiplying through by 1 over x. Since this v and this v are on one side, we multiply through by 1 over x. So we're left with 1 over x minus 4v squared minus 4v dx is equal to 2 plus 3v dv. The 1 over x will cancel out this x, which is 1. So we have dealt away with the x. So now we have the x on one side, the x on one side. We have v on one side, the v on one side. What is hindering the equation now is this minus 4v squared minus 4v on this left-hand side. So what we are going to be doing is dividing all through by minus 4v squared minus 4v. So that is what we are going to be doing. We have minus 1 over x. We then have minus 4v squared minus 4v divided by minus 4v squared minus 4v is equal to 2 plus 3v divided by minus 4v squared minus 4v dv. So now this is going to cancel out. Okay, our dx is going to be 1 over x dx is equal to 2 plus 3v divided by minus 4v squared minus 4v dv. So now we are going to be integrating both sides. So it's going to be integral of 1 over x dx is equal to integral of 2 plus 3v minus 4v squared minus 4v dv. So now we'll be integrating this first and later integrating this one secondly. So let's write it out. We can also see in the denominator, we have minus 4 common here and also minus 4 common here. So let's take it out. So it's going to be integral of 2 plus 3v divided by minus 4 v squared plus v. So let's rewrite this equation. It's going to be integral of 1 over minus 4 2 plus 3v v squared plus v dv. So now we are going to be integrating this function with partial fraction. So let's write it out. So this is going to be 2 plus 3v divided by v squared plus v. If you don't have the idea of integration by partial fraction, you can go online and also search integration by partial fraction and you get the basic idea. So now let's write it out. So this is also 2 plus 3v v plus v plus 1. So this is using the integration by partial fraction. You write a divided by v, one of the parameters, plus v, b, divided by v plus 1. The idea of the integration by partial fraction is basically decomposing the main equation, which is this, into smaller equations that we can differentiate. So we are going to be multiplying this by this by this is basically taking an LCM and equating it to the first equation. So a multiplied by v plus 1 plus b multiplied by v is equal to this main equation, 2 plus 3v. So now the idea now is we want a value that will make here 0, we'll then get b. And also we want a value that will make b 0, we'll then get a. So think of a value that will make a equals to 0. So when we need a value that will make v, this section 0, then a is then going to cancel out, then b value will then be present. So when v is equal to minus 1, a will be 0. So let's check it out. A minus 1 plus 1 plus b minus 1 is equal to 2 plus 3 minus 1. So a is 0 minus b is equal to 2 plus 3 minus 1. So this is 2 minus 3, which gives us minus 1. So now minus b is equal to minus 1. So b is equal to 1. It's the same idea now we are going to be using to walk through with a. So now we'll be looking, since we have gotten our value of b equal to 1, we'll be looking for the value of a. So we need a value, and when we substitute it into this portion, whereby this v, we want b to be equal to 0. And now we'll do the same thing, put the v here and also put the v here. So which value can we think of that will make b 0? So if v is equal to 0, if v is equal to 0, a 0 plus 1 plus b 2 plus 3 is 0. So a is 1 plus 0 is equal to 2. So a is equal to 2. So now we are going to be substituting the values we have gotten into this equation. So we have 2 over v plus b is 1. 1 over v plus 1. We should not forget that we have a minus 1 over v. So it's going to be integral of minus 1 over v. So now we are going to be dv. We are going to be integrating this separately. So it's going to be minus 1 over 4 2v dv plus integral of 1 over v plus 1 dv. So breaking this down, we'll be breaking this out, we'll take this 2 over to this side. So it's going to be minus 2 over 4 integral of 1 over v dv minus 1 over 4 integral of 1 plus v plus 1 dv. So this is going to be minus 1 over 2. If you integrate 1 over v, it's going to be giving you ln v minus 1 over 4 ln v plus 1. So we have integrated the first section. We will then integrate 1 over x dx. So if you integrate 1 over x dx, it's going to be giving you ln x plus c. So now we are going to be equating this with this from this idea we have gotten here. So it's going to be ln x plus c is equal to minus 1 over 2 ln v minus 1 over 4 ln v plus 1. So we can also remember that y is equal to vx and v is equal to y over x. So you can also substitute this v is equal to y over x and break it further down to get a more simplified version. But this is where we are going to stop due to the complexity of this equation. Make sure to like, share, and subscribe. And any question you have, leave it in the comment section. Thank you.